friends, Shinner's back here. We are talking about 9.21 today. 9.2.1, what if the quantities are not equal? So we are focusing on inequalities for the next couple weeks here, which is exciting. We haven't quite talked about these yet in Algebra 1. Maybe you've seen these in a previous math course. Maybe you haven't. But inequalities are cool because instead of having just one solution, we will typically have solution sets. So a range of values that make an inequality true. So I really like these. And that kind of lends us to our question of the day. I want to know what is one of your favorite things or your favorite thing about online school? So virtual school, we're in it, right? What is something you like? I like the flexibility, right? So to kind of tie it into what we're doing today, I like that there's, a range of times where you can do each class, a range of times where you can wake up, right? So, based on each of us, based on our schedules, our homes, what we got to do, what do we got to get done, right? We can all build our own schedule that works for us. And I love that, right? I think that's really cool. And so that's, we have a range of possibilities instead of one schedule. First hour algebra 723, right? Where we know probably there were days where not all of us were ready for algebra at 723. So that's the cool thing about online school, and that's the cool thing about inequalities is we now have ranges of possibilities. So we are going to jump in here, guys. We are going to do this warm up, getting us thinking about inequalities and ranges of possibilities, okay? So is $200 a solution to the following inequalities? Okay, so $200 is my number. So I want to rent an apartment for more than $500 per month. Would $200 be in that solution set? No, right? $200 would be less than $500. That would not be a possible apartment, right? For the person who wants to rent for more than $500, okay? What about I want to rent an apartment that is $200 or more with a max of $400, okay? So this is way more real life of having a range that works, right? So would $200 be a solution here? It would, right? It would be on the lower end of this person's budget, because $200 or more, 200 would be possible then, right? $200 or more, $200 is that boundary point. And because it says 200 or more, it would be a solution, okay? So that's how inequalities, that's kind of the basics of how it works. But, for math, we don't usually write things out as sentences. We like to use some symbols, right? Shortcuts and things like that. So this table is going to get us that symbols to work with. So less than is this symbol here, kind of looks like a slanty L. Greater than is just the flip of that. Less than or equal to means I'm including that boundary point. So that would be like kind of like this example where that boundary point was included. Greater than or equal to, right? So think about the or equal to as being like the express checkout lane, where it's like you must have 15 items or less. 15 items or less. Okay, so if I have 15 or 14 or 13 items, I can go in that line. So so these two are examples of when we include the boundary point, and these two are when we do not include the boundary, okay? Okay, so how we represent that on a graph then, if I'm not including the boundary, I want to keep that point on the boundary open to symbolize that I'm not including this point, it's just my boundary, it's just my cutoff, okay? Whereas if I am including that boundary point, I'm going to fill in the point to symbolize that that is a solution, that is part of my solution, okay? So just like 200 was a part of this solution, so I wanted to fill in that point. But if I want to pay more than 500, then 500, my boundary point would not be included, okay? And we'll do some examples, okay? I promise. Hopefully it'll make more sense too as we practice, okay? So 9-46, let's practice this. So write an inequality that represents the solutions on each number line below. I'm just going to use the variable x because I see that on the number line here, but you can use any letter you want. I don't really care, okay? but I see that I have a filled in dot, so I should be on this part of my table. And I see that I'm shading to the right. Okay, so numbers to the right of X, that would be numbers that are greater than, right? So I want to use this symbol, or equal to 1, okay? Because it's filled in and it's to the right, okay? What about problem B? Okay, my boundary point is still 1, but the point is open. So that means I'm on this side of my table, and I'm shading values to the left of 1. Left means less than, so it would be X is less than 1, okay? So that's kind of how that works. 9-47 gives us an inequality and asks us to solve for the graph on the number line and the inequality, okay? So I'm trying to get these two things from this inequality here, okay? So we've got to add in one additional step here, and that is to solve for the boundary point. So how do I get my boundary point if it's not super obvious? You just have to do a little bit of algebra, right? So what I have to do is I have to change that inequality to be an equal sign, and that will give me my cutoff. That's going to give me what is the number that is between the solution and the not the solution, right? The boundary, 15 items or less, right? Or you've got to be 10 or older to ride the ride, right? Those are boundaries, okay? So for my boundary point, I got X equals 4. So let's plug in, I've got 0 over here, 1, 2, 3, 4 here, 5, 6, 7 would be over here, right? Okay, so 4 is my boundary point. Right away, I know that it's going to be a filled in point because I have greater than or equal to. So let's fill in that point on 4. And now I just need to figure out which way am I shading, okay? So do I shade to the left or do I shade to the right? So how I'm going to figure that out is I'm going to try to plug in 0 and see if it makes a true inequality, okay? So just pick a point to the left of 4 and let's see if it's a solution. If it is a solution, that will indicate that then to the left of my boundary is the rest of my solution, okay? So we're going to kind of plug in and check, similar to what we did with systems a little bit. All right, so let's substitute in 0. I get -5 is greater than or equal to 3. Is -5 greater than or equal to 3? Heck no, guys. So it doesn't look like to the left is going to be a solution. Let's pick a number to the right of 4 to see if that works. Okay, so I'm plugging in 5 for X now. 2 times 5 is 10. Okay, 10 minus 5 is 5. Is 5 greater than or equal to 3? Yes, it is. So I know my solution is going to be to the right here. So we want to shade to the right, okay? So you can kind of fill in your number line. I like to then block off the arrow to show that the solution set keeps going. Alrighty, so now I just need to write that as an inequality. So that's what we did above here. That's just going to be X is greater than or equal to, since it's filled in, 4, right? 4 is my boundary. My solution is to the right, so it's greater than or equal to 4. Cool? Alrighty, I know this is new, so we're going to practice this for a while, so don't freak out if you're like, what is happening? Let's try another one, okay? So we're going to first solve for the boundary point. So we're just going to swap in the less than for an equal. And now I'm going to solve for my boundary. So let's subtract 3 and then divide by -2. And I get a boundary point of X equals 1, okay? So I always like to put 0 in the middle. 1 is over there. And then we also got to find a point to the right, okay? Should it be filled in or open? It should be it should be open, right? Because there's no or equal to, it's just less than. So I'm going to leave that point open on 1. And now I'm just going to test, okay? So let's plug in 0 to the left. All right, and I get 3 is less than 1. That is untrue. So I just kind of X off the left. And now we're just going to plug in 2 and make sure it works on the right. So 3 minus 4, so I get -1 is less than 1. That is true. So I shade to the right again. Okay, and leave that point open. And so my inequality would be x is greater than, because I shaded to the right, no or equal to, because the point is open, 1. X is greater than 1. Alrighty, so that's the big idea of inequalities here today, folks. Let's get started on the review and preview. I'm going to walk you through part B over here, just because there's a little bit a step here where we got to distribute the 2. So let's solve for our boundary point, right? This is the same process. So I'm just going to rewrite this, set it equal to -4. I'm going to distribute that 2 through, so 2 times 3p is 6p. All right, -2 gives me 6p equals -6. So I get p is equal to -1, okay? So put 0 in the middle. -1 is our boundary point. That should be an open point. Since it's just a greater than, there's no or equal to, right? This one will be a closed because it's greater than or equal to. So leave that open, and then I need 1 point to the left, 1 point to the right, and we're just going to plug each of those in and find, which way do I need to shade, okay? So let's first plug in 0. Okay, so 3 times 0 is 0, so I just get this. Is 2 greater than -4? Absolutely it is, okay? So 0 does make sense in this case, so I'm going to shade to the right. Okay. And what would that then be for an inequality? That would just be p is greater than -1. Okay. Cool beans. And if you want to check your work, I do think it's good to plug in -2 and make sure that it doesn't work, just so that we know we did everything correct, right? Because that's to the left, so it shouldn't work, right? Because it's not part of our solution. Okay, so -6 plus 1 would give me -5. So I would get 2 times -5 is greater than -4. So I get -10, which is greater than -4. Oh no, that does not work, right? -10 is not greater than -4. So we know we're right, okay? Does that make sense? So just to make sure you shaded the right region, it is good to get one that works, one that doesn't. So you're like, yep, I'm good to go. All right. All right, so we're going to have you try letter B. Your teachers are going to check that one closely because that's kind of your check for understanding today. And then we've got a couple quadratics, and then 9-53 is just true, sometimes true, always true, or false, never true. So if you want to write false instead of never true, that's fine. So just is -4 less than or equal to 9? That's always true, right? Always is that will always be true. -5 bigger than -2, that's always false, right? That's never true. So if you need to see a number line, I would urge you to just Google number line. If you're like, well, I'm kind of like getting turned around here, right? So if it's greater than, it will be to the right of the number. If it's less than, it will be to the left of, okay? So finish up the backside here, guys. Good luck. Let me know if you have any questions.